is Naluja Ashley Hope and I'm part of Group 6.
My name is Akunda Praise and I'm part of Group 6.
My name is San Emmanuel Ezekiel and I'm part of Group 6.
This is Laiwan Chibugi. This is Group 6. Yeah.
Linda Mark, like my colleague said, Group 6.
So basically this is a MiniHealth project. So I'm going to call my colleague Ayman to give an overview of the project. Thank you.
So good afternoon again. So I'm going to give an overview. I'm going to give you an introduction to this system of ours and how it's going to be working. So essentially this is a MiniHealth system that is going to be taking heartbeat and the temperatures of a person, and when it reaches a certain amount, it can alert the people in charge that maybe the temperature is beyond the required. So the way this works, I'll show you on the board how everything works. So we have four Arduino boards, and these are what is going to help us is achieve this. So we have 4 boards with this as per the report. We have this. We have 4 boards. This is board A, according to the report. You see it. This is board A that manages every other thing on this platform. This is board A. This is board B, and this takes the temperatures of the human being or whoever it is that you want to take the temperature, and this board will do the heartbeat. Will tell you the heartbeat, and this will do the data logging of whatever is going on. So this board is connected to this, and this is the sensor for the temperature. This is the sensor for the temperature, and when the temperature is gotten, it will be sent to this board, which is board A, which controls everything. Then we have this for measuring the MBPs, and this is used for measuring the heart rate. So how this works is if I press this button, this tiny button, I can alter between whether to measure the temperature of a person or the heart rate of a person. So right now it's the heart rate. When I keep on tapping this sensor, you see that here the heartbeat will be changing depending on the rate at which I tap this. If I increase it, then it will go on increasing like that. Yeah. The reason why I have to tap instead of taking the temperature is because this sensor is not sensitive enough to pick my actual heart temperature. So I have to beep it to give it the illusion that it's actually the heart. So the other thing, if I wanted to take the temperature of whichever thing, for example my body, I would trigger this. When I press it, this LED will show that this system is back on, and it will trigger to the temperature bit of it. So right now, if I touch this sensor, I'm supposed to get the temperature of my body, and as you see it here on the LCD, it is going to keep on increasing. It will keep on increasing until 32, because that's where we set it. And when it reaches 32, it will light red here. It will light red. Hold on. I think my temperature is not so high at the moment. So when it reaches 32, this LED has to light up to signal that the temperature has gone beyond and maybe it's critical or something. Yeah, so you can do something about it. Yeah, so essentially that is everything on this platform, and I'll right now call upon my colleague to take you through the in-depth of how exactly everything works.
So he has given an overview of everything mostly. So maybe doing a deep dive into all this is an LCD. Temperature sensor is an LM35. This is a pulse rate sensor. These are all Arduino Unos, and they are communicating through the SPI protocol. So like I said, this is the main Arduino. This is the one for the temperature. This is the one for the heart rate. This is the one for data logging. So as the results keep being fetched from either Arduino, so let's say this is the temperature board now. if it gets the temperature from this board receives the temperature, shows it on the LCD, and then pushes it here for data logging. And then if I switch to this board of the BPM, it gets the BPM also from this board, gets it to this board, and then sends it to the data logging. So that's how the system works. And then maybe a few more extra details. As he said, this temperature is supposed to exceed a certain threshold. Sorry, change this to board 1. This temperature is supposed to exceed a certain threshold. So normal body temperature is supposed to be 37. But since we cannot put this thing under our armpits, that's when it will exceed 33. So like you see now, when I touch it, exceeds 33. The LED goes on red and it goes on the buzzer. So just for like demonstration purposes, I can lower this temperature threshold to like 30 just for something. But maybe let a colleague of mine first come and try it. Let's hold that LED. See if this temperature goes to 33. Environment seems quite cold right about now. Okay. Now let me just change the code here to point to something like 30, which is easily reachable.
Just a few minutes back.
And I push it back to the, Now, if we come here and we see the temperature is already above 30 in this room, so the red light is on and the buzzer is on, and it keeps on increasing. Now, if I leave this temperature to reduce below 30, now it has reduced 29. Now the LED is off and the buzzer is off. And then, like he also said, this is the LED, so it's connected to this Arduino. So as long as Arduino is on, this LED is going to be on. Then maybe more on SPI, it's master in, slave out, master out, slave in, then the clock line, then the slave line. So if you look at all these wires here, this Arduino, like I said, is the master. So these 3 wires, they're connected to this breadboard. Master in, slave in, master out, slave in. And then on the individual boards, there's going to be a slave line for each of them. So on this main Arduino, I mapped pin 11, the first slave line, to be this one, and the next slave line to be this board, then the last slave line to be this board. So essentially that's how they communicate. And yeah, I think that will be it from us today. Group 6 signing out.
Peace.